Okay, kiddos, so now we're going to move on to blood typing, which is one of the final concepts for this particular unit, and it's kind of interesting actually. The different blood types, there's different ways to classify them, but the most commonly used system is the ABO system, and so that's the one that we're going to be focusing on. And so we already talked a little bit about antigens and what antigens are, and remember that antigens are proteins or protein markers that we find on the surface of cells. And when we are talking about blood cells specifically, red blood cells specifically, we call these antigens glycoproteins. Okay, so antigen is kind of an umbrella term. Glycoproteins are specific to red blood cells. So depending on what blood type you are, your blood cells will have a different glycoprotein from someone who has a different blood type. So in other words, individuals with an A blood type have the A version of the glycoprotein or the A antigen, and people who have B blood types will have the B version of the glycoprotein. So the glycoprotein is different between people that have A and B blood types. So that's why you can't just randomly transfuse the blood of a type A person into a type B person, okay, because that can have deadly results. So individuals who are considered AB blood types, okay, so I'm sure you've heard of AB positive, AB negative blood types. They actually have both glycoproteins, okay, so they have the A antigen and they have the B antigen. Now, O, blood type O, individuals have neither, so they do not have the A antigen and they do not have the B antigen, okay, so you can consider them antigenless. And so it's believed that when the using the alphabet like the A and the B, sometimes kids will ask, well, how come they didn't use C? And the belief is that the O came from zero for like zero antigens. Okay, so not super scientific, but that's believed to be what the explanation is for that. So if we take a look at our graphic, our little kind of blue circle represents the A glycoprotein or antigen A, and the little yellow circle represents our B antigen or our B glycoprotein. Okay, so if we take a look at anybody that has blood type A, they obviously have the A antigen, so the little blue circles, but not the B antigen, so no yellow circles. If a person is blood type B, that means they have the B protein or the B antigen on the surface of their red blood cells, but not the A antigen. And then you'll notice, like we said, someone who's blood type AB, that means they have both. So you'll notice they have both the blue or the antigen A proteins and the yellow or the antigen B. And then of course, finally, we have our group O, and you'll notice that our red blood cell for group O is smooth and clear of antigens. So no A antigens and no B antigens on blood type O. So if we take a look at the difference between antigens and antibodies, please remember that antigens are the proteins on the surface of the red blood cells, and antibodies are proteins that our B cells produce to fight off foreign invaders, okay? So when we take a look at our graphic over to the right here, you can see that in terms of our legend, you can see that the type A antigen in this particular graphic is represented by little yellow circles. Type B antigen is represented by the kind of look like little candy corns, kind of little triangular sort of shapes there. And then, of course, hopefully these Y-shaped structures, these distinctive looking Y shapes are familiar to you by now because those are actually antibodies. Okay, so if we look at a person with type A blood, that means that their blood cells have the A antigen, and therefore, if they were given the wrong type of blood, if they were given type B blood, then their bodies would actually make antibodies against the B antigen because the B antigen is foreign to people that have type A blood. So you'll notice that if you have the A antigen, you don't have the A antibodies because you wouldn't want your own antibodies to be attacking your own red blood cells. And if we look at our variable region, okay, like we said before, you can see that on the B antibodies, there's that sort of V-shaped variable region, and that's going to fit these little kind of triangular shaped proteins, right? So likewise, if someone has type B blood, that means they have the type B antigen, and conversely, they're going to make anti-A antibodies. So they're going to make antibodies that are going to protect against the antigen or the foreign protein that would be found on type A blood. Now, notice that our next one here, so this is our blood type AB, notice that they don't have any antigens for A or B. And that's because, remember, if you're a type AB blood, that means you have both the A antigen and the B antigen. So you're not going to make either antibodies to attack your own blood cells because your blood cells have both of those proteins. And then you'll notice for our blood type O person, you'll notice again, we're nice and clear of antigens, but that means that, of course, a person with type O blood, if they receive a transfusion from someone with a different blood type, they're going to have antibodies for both type A and type B antigens. Okay, type A and type B antigens, because the type A and type B antigens would be foreign to a person who has type O blood. And if we take a look at our little graphic over here, this kind of shows us the antigens versus the antibodies, okay? So if we look at our blood type, a person with blood type A, for example, has the A antigen or the A protein and B antibodies. A person with type B blood is going to have the B protein or the B antigen and therefore make A antibodies. So it's going to make the opposite of what it has. A person who has AB blood has both antigens, so it's not going to make A or B antibodies. And notice that a person with type O blood, again, they have neither antigen, they don't have the A or the B protein, and therefore they will have both antibodies. So that's kind of the foundational concept when it comes to understanding the difference between antigens and antibodies. So if the protein or the glycoprotein or the antigen, whatever you want to call it, of the donor's blood is foreign to the recipient, then we have an immune system called agglutination, which will occur. So what this means is if a person who had type A blood, for example, accidentally received a transfusion from a donor who was type B blood, agglutination would happen because the person who has the type A blood would make antibodies against those B red blood cells. And basically those antibodies would attach onto the surface of the red blood cells, cause those red blood cells to immobilize and eventually clump together. And that's what agglutination is. It's the clumping together of red blood cells as a result of an improper blood transfusion. So by definition, the clumping of red blood cells caused by antibodies attaching to antigens when there is an incompatible blood transfusion. And what it ends up doing is inactivating the RBCs, and a person can eventually die from oxygen deprivation. So if we look at our little graphic here, and notice we aren't using the Rh factor yet, because we talked about how blood types can be A positive or B positive, A negative, B negative, etc. Right now we're just focusing on the ABO, not the Rh factor, okay? So if we take a look at the donor versus the recipient, so we're going to go this way, we're going to see if we can figure out which donors can give to which recipients, okay? So we kind of got you started here. So what this means is if we go this way, and remember this is our donor on this side here. So a person with type A blood, can they donate to a person with type A blood? The answer is yes. Can a person with type B blood donate to another person with type B blood? Yes, and so on, right? But now what we want to look at, if we continue to go across here, is can a person with type A blood donate to a person with type B blood? And the answer to that would, of course, be no. So we would put a little negative sign there, right? Because if a person with type A blood donates to a person with type B blood, the person with the B blood receiving that transfusion is going to make antibodies against that A antigen. Now, can a person with type A blood donate to a person with type AB blood? The answer to that is actually yes, because if a person is type AB, that means they have both antigens, and so they're not going to make antibodies against that A blood. Can a person with type A blood donate to a person with type O blood? And the answer, of course, there is no, okay? Because a person with type O blood has neither the A antigen nor the B antigen, so they're going to have both types of antibodies that will cause agglutination because the donor's blood cells will be attacked by the antibodies in the type O person. Okay, so you try and figure out the rest of this and make sure that you understand that pattern based on what we talked about with antigens and antibodies. So sometimes there can be complications with respect to the rhesus factor and pregnancy. Now, we talked about the A antigen, we talked about the B antigen. There's also an antigen called the rhesus factor that is found on red blood cells too. So this is where we get that positive and negative that we talked about before, like how we can have an A positive blood type, B positive blood type, AB negative, et cetera, et cetera. And so rhesus comes from the fact that this second antigen was discovered on blood work that was done on rhesus monkeys. And so that's where the name rhesus comes from. And then, of course, we abbreviate it RH, okay, for the RH factor. So this is what we call a discrete characteristic. So that means that you're either Rh positive or you're Rh negative. You either have that Rh protein or you do not. Okay, so there's no, oh, I kind of sort of have it or a little bit of it, or sometimes I have it. It's you do or you don't. You're either Rh positive or you're Rh negative. There's nothing in between. Okay, so what happens then if during pregnancy a baby inherits the Rh factor? Okay, so let's say that the father is Rh positive, and then of course it passes on that Rh positive to the baby. But the mother is Rh negative. Okay, so we're just concerning ourselves with the rhesus factor here, not with the A and the B blood types. So what you need to remember here is that Rh is a protein. So that means the baby, as it's developing inside the mother's womb, has that protein. The mother, however, does not have the Rh protein. That Rh protein that is in the baby's bloodstream is actually foreign to the mother, and therefore the mother has the potential to make antibodies. So because blood doesn't mix between people on a regular basis, typically speaking, especially with the first baby, there really isn't usually an issue because the mother will not likely have antibodies against the Rh protein. And so usually it's safe for the first baby because the mother system will not have antibodies. Okay, so where it can become problematic is with subsequent pregnancies. So let's say, for example, during that first pregnancy and during the delivery, let's say that there was a torn placenta or there was surgery involved, cesarean section or whatever, and let's say that the mother's blood and the baby's blood mixed during that first delivery. So that baby would be okay. But what you need to think about is the mother's immune system, if the blood has mixed, has now been exposed to that Rh protein. And as a result, over time, the mother's immune system is actually going to make antibodies against that Rh factor protein because that's foreign to the mother. She doesn't have that Rh protein. It is considered to be a foreign invader. So her system over time, as a result of that exposure to the baby's blood, is going to make Rh antibodies. So that's why it's the babies that come after that first one that there's the potential for it to be problematic. Okay, so if those antibodies are produced, any subsequent fetuses after that first baby that are Rh positive, not if they're Rh negative, that's not going to matter, but if they're Rh positive, they have the possibility of the mother's antibodies actually attacking and agglutinating the baby's blood. Okay, now it used to be back in the day that people always used to have they used to always have to get blood type testing done before they could get married and get a marriage license because of this complication. But now it's not a huge issue. They just are aware that there might be some blood type incompatibility with the pregnancy. And as a result, there's medication that can be taken, or sometimes it involves a transfusion of Rh negative blood into the baby at birth because that allows time for the mother's antibodies to actually break down in the baby's system without doing a bunch of harm. Okay, so it just kind of depends on the protocol given the circumstances. So the term that we give to the clumping of blood in the fetal bloodstream is called erythroblastosis fetalis. And again, this is a condition that can occur when you have an Rh negative mother and an Rh positive baby in those subsequent second or third or whatever pregnancies. So this graphic is good because it kind of gives us what we're looking at. So you can see the mother is Rh negative. The baby, however, is Rh positive. So there is the potential for the antibodies that the mother possibly made during the first pregnancy, if there was mixing of blood between mother and baby, and that first baby was Rh positive, there is the potential for those antibodies to actually attack the baby's red blood cells and cause agglutination and brain damage sometimes, or even death. So our next concept is to take a look at how do we actually do blood type. So I always ask kids, do you know your blood type? Like, for example, I know that I'm O positive. Okay, so that means that I do not have the A or the B antigen, but I do have the Rh factor. Okay, so no A or B proteins, but I do have the Rh factor. And you can get Canadian Blood Services to do your blood typing. Sometimes they come into the school, but I think you have to be 17 for that now. But it's actually a fairly simple process. So testing one's blood type can be done by mixing different serum with a blood sample. Okay, so testing one's blood type is done by mixing anti-A and anti-B serum with the blood and identifying where there is agglutination. Okay, so as we were saying, when we have that, okay, so as we were talking about agglutination and the serum, all right, so when we talk about anti-A serum, I want you to think of this little prefix here, anti. When you think of that prefix anti, like antibody, or I'm anti-government, or whatever, I'm anti-body shaming, all of those things mean you're against it, right? So if we have anti-A serum, what that means is it is against A antigens. So anti-A serum is going to contain antibodies that attack that A protein. Anti-B serum, likewise, okay, if it's anti-B serum, that means it's against the B antigen, and therefore it's going to make B antibodies that will attack any red blood cell that has that B antigen. And then, as we already said, agglutination, of course, is that clumping or coagulation, that irreversible change as all those red blood cells become immobilized and clumped together, caused by the antibodies attaching themselves to the red blood cells and immobilizing them and resulting in that agglutination process. Okay, does not want to go forward. That's so annoying. Okay, there we go. All right, so the other concept that we have to kind of know here is how do you actually interpret blood typing responses? And the other thing is that I should have mentioned on the previous slide is, so we have our anti-A, we have our anti-B sera, and then we have our anti-D. And the anti-D is for the Rh factor, okay? This is for the Rh protein. So we have one little spot where we're going to add anti-A serum to the blood smear. We have a second spot where we're going to add anti-B serum to the blood smear. We have a third spot where we're going to put anti-D serum, which is for the Rh factor. Okay, and then we have a control. And remember, the control is always our reference point. So that's so we can see the difference between a smear that is agglutinated and a smear that is not. Okay, so if we look at Timmy Monkey's blood type card here, you can see that he is O positive. Okay, so you'll notice on the blood type card, it says for the ABO, we have O, and for the Rh factor, we have positive. So if we go back to our little blood smears at the top here, we added anti-A serum, and we had no coagulation. Okay, we just had a blood smear, and we can compare that to our control. And so what that means is the anti-A serum that has A antibodies, okay, to attack the A antigen, didn't do anything. Likewise, we added anti-B serum here. So the anti-B serum that has antibodies to attack the B antigen did nothing. However, when we put anti-D serum, which has antibodies that attack the Rh factor protein, we got agglutination. Okay, so that's why it's O positive. So no A antigen, no B antigen, but clearly, as the agglutination is evidence of, we have the Rh factor protein there because the anti-D serum resulted in agglutination of that third blood smear, identifying the fact that the antibodies in that serum clumped up the blood sample. So therefore we have the O positive result. So here's just a couple other ones to do to make sure that we understand what these blood types are based on these blood typing cards. So anti-A, we have agglutination. Anti-B, we have agglutination. Oh my goodness. And Anti-D, we also have agglutination. So if we take a look at that particular blood type card, then we can say that this person is AB positive because they had agglutination in all three sera. If we go over to our next one over here, it looks like we have agglutination in the anti-A and agglutination in the anti-B, but no agglutination in the anti-D. So this person would be AB negative, okay, negative because no agglutination in that anti-D or Rh factor 1, right? And then our last one here, let me see if I can see this one. So this looks like no agglutination in the anti-A, no agglutination in the anti-B, but agglutination in the D. So this person would be O positive, okay? Okay, I hope that helps, kiddos.